I think a good first question would be an exam question like this. Now, this is from paper 2, but it has stuff about straight lines that maybe helps a little bit with paper 1 as well. So let's start by looking at this. And it says ABCD is a parallelogram. So notice how it's in alphabetical order. And I want you to find me the midpoints of AC and BD, which are diagonals of this parallelogram. So the one diagonal AC is here. The other one doesn't have its own line, but it goes like that. So 2.1, see if you can do that. And you remember what the midpoint formula is. So for AC, I get 1, 0. So for the midpoint of AC, I get 1, 0. For the midpoint of BD, I still need to work it out. So that's 2 of 2s I get. So what I'm seeing is that the midpoints are actually the same point. So the midpoint is 1, 0. So X is 1, Y 0. So they're saying the midpoint is there. And what that means is if it's the midpoint of the yellow diagonal, we would put one line like that. And if it's the midpoint of the blue one, we put 2. And the reason we do that is we're showing, look, these diagonals aren't equal, but they are cutting each other in half. Okay, 2.2. What can we deduce? What can we get from 2.1 about the diagonals of the parallelogram? What do we know from 2.1 because of this calculation? What does it tell us about the diagonals? Who would like to offer a comment or a deduction? What does it mean if we have common midpoints for the diagonals? What does it mean about the diagonals? And remember, these are diagonals in the parallelogram. What do you think, Loyola? Or Mampema, Kasani, Fetejo, what do you think? What do we know? If we see that diagonals have a common midpoint, I kind of mentioned it now. What does it mean about those diagonals? So Loyola, it doesn't mean they're equal. Because if you look at the visually, can you see the blue one is much longer than the yellow one? So it doesn't mean they're equal in length. Angles equal the same. Not too bad. What it means is the diagonals bisect each other. So the diagonals bisect, we just say. And what that means is that the yellow diagonal is cutting the blue diagonal into 2 equal halves. So can you see how like the yellow one is like a knife and it's slicing the blue one into two big halves. And then the blue one is like a knife slicing the yellow diagonal into two smaller halves. So when you have a common midpoint, you know the diagonals bisect each other. And the reason you know that is because they have common midpoints, right? You can see the common midpoints above. Okay, 2.3. It says, calculate the gradients of both AC and BD, and then say what is the relationship between these two lines. So I want you to work out for me the gradient of AC, the gradient of BD, and then I want you to know about the relationship. And on your formula sheet or on the screen now, you can find the formula for gradient. We'll do here, no problem. Okay, so we are finding the gradient. Let's look here. Make co-host. There we go. Okay, so if we think of the gradient of AC, I'm going to go 2 minus minus 2, and then I'm going to go 0 minus 2, which gives me 4 over minus 2, which gives me minus 2. And that looks like a negative gradient, so that's fine. And then for the gradient of BD, I'm going to go 3 minus minus 3. So watch out for these double negatives. And then I'm going to go 7 minus minus 5. Now notice how I started with D and worked and subtracted B. You need to be consistent. It doesn't matter which one you start with, but you need to be consistent. And so here we're going to get 6 over 12, which is a half. Now, it says, calculate the gradients and then say what is the relationship between these two lines. I want to know what is the relationship between the big blue diagonal and the smaller yellow diagonal. They're equal. Okay, you're on the right track. So what it means is if the gradients multiply to minus 1, right? So you can see minus 2 times a half, minus 2 times a half equals, you can put a 1 there, so you get minus 2 over 2, and then you get minus 1. So the gradients multiply to minus 1, and that means that AC is perpendicular to BD because AC times gradient of BD is minus 1. So basically we're saying that that's at 90 degrees to each other. Thumbs up if you understood that, thumbs down. So please re-explain what you did after finding the gradients. So what I did was I multiplied the two gradients together. And if the two gradients give you -1, then you know that the diagonals are at 90 degrees to each other. If the gradients were the same, they would be parallel. So if two gradients are the same, they're parallel. If gradients are negative reciprocals, or if they multiply to -1, they're at 90 degrees. And if they're neither of those two, then they're called converging lines. And eventually they will just interact. There's only 3 possibilities. Okay, 2.4, it says hence. So refer back to what we did. Name the type of parallelogram that ABCD is. What type of parallelogram is this? Now we know it's a parallelogram. The diagonals bisect, but the diagonals bisecting at 90 means it could be other types of so it can't be a kite because we know it's a parallelogram, right? So a kite can't have two parallel, but you're on the right track, Lolo. You're in the right part of town. But a kite has these 2 pairs of adjacent sides equal, and the diagonals do, well, they don't bisect each other, hey? The one's longer, so it doesn't have the property so far. But what else could it be? Who thinks they know the answer for 2.4? So it's a special type of parallelogram. It's called a rhombus. And a rhombus is kind of like a pushed over square. And the reason that we know it's a rhombus is we say the diagonals don't just bisect. They bisect at 90 degrees. So that's the official reason. We've shown that they bisect in 2.2 because of the common midpoints. And then we've shown that they are perpendicular because of the relationship of the gradients. And so together, we say the diagonals bisect at 90. And so it's a rhombus. Okay, so that is a rhombus. On to 2.5. 2.5 says, determine the equation of the line AB. Now, this is a different part of town because AB is not a diagonal. It is a side of the rhombus. And I want you to use your straight line skills that are applicable in paper 1 and paper 2 to find me the equation of that line while I clean the board. Oh, yeah, can you still see the screen okay? I'm just having a look at something. Just want to check that you can see the screen.
Yes, but it's quite smaller than usual.
Okay, let me see if I can make it bigger and get this other thing going. Let's see if I can. Oh, no, I just made it up. Unhappy. Okay, is it back to normal now?
Yes.
This is good news. Okay. So what is the equation of the line? Well, for any line, I need the straight line formula. So mx plus c, I need a gradient. So I'm going to go 2 minus minus 3 over 0 minus minus 5. So my gradient is 1. And actually, if I look at this, it's cutting the y-intercept at 2. So it actually has to be y equals x plus 2. I could sub the point in 0, 2 to find c, but I can literally see it. So we know the equation of the line AB is y equals x plus 2. Now, the next part of the question is I want you to find K if the X value or of the X intercept. So K is sitting over here. And I want you to use the equation of the pink line you figured out to figure out what the value of K is. Okay, so if we want to find the X-intercept, all we need to do is make Y 0. And so we should then get X is -2, or the point H will just be -2, 0. Okay, then starting to get a bit more interesting. Determine the magnitude of BAC. Now, where is the angle BAC? It's going to be BAC. So let me even zoom in a little bit. So there is the angle BAC. Now, that looks a little bit random, but what I want to suggest is there is a connection between this angle, I'll call it the green angle, and this angle over here, which I'm going to call the blue angle. And the green and the blue can help us figure out the red. What is the relationship between the green angle and the red and blue angle? Who can remember from their geometry? Exterior angle equals the sum of the interior opposites. Absolutely. So then, is there a way that we could work out the gradient, or sorry, the size of the green angle, the size of the blue, and then eventually the size of the red? So I was thinking, if we know the gradient of AC and we know the gradient of AB, there's another formula. Loyolo, magnitude just means size. What is the size of the red angle? So earlier in this question, we worked out that the gradient of AC was 2 minus, so it's 4 over, so that was -2, and the gradient of AB we worked out was 1. What formula will connect the gradients to angles? I think we did a bit of this in the last lesson. What formula do we need to connect the gradient of straight lines to angles? Yeah, so tan theta equals m. So if you can find the blue and you can find the green, you should be able to find the red. See if you can do that. Otherwise, pop your hand up if you have a question. So probably the easier one to work with is to say, look, the blue one is just going to be tan of theta equals 1. What is the theta going to be for that? And then also there's a little bit more work with the second one because it's a negative. But if you look at what it looks like, you know it's an obtuse angle. So I want to know for green and for blue, what are the size of the angles that we get? And we're using stuff that we had earlier. We worked out the gradients earlier in the lesson, in case you're just joining us now. So for this one, when I go shift tan of 1, I get 45 degrees. And Josh agrees with me. So we know this angle over here is going to be 45. What is the green one going to be? Now, it's a little bit more complicated because of the negative. But I want to see, can you get me the size of the green one? Now, if you get a negative angle, you need to do something to adjust that. You might end up getting this one over here, and then sometimes you need to, if you get that one, you need to hop to this green one over there. We know that one was 45. And we know the reason is exterior angle. Triangle. So there's two ways to get the answer for the green angle. You either go shift tan -2 and add 180, or you ignore the negative and go tan is negative in the second quadrant and you go 180 minus, but you should end up with 116.57. Okay, last step. How do I get the red? How do I get the red angle? What is the size of the red angle or the angle BAC that I was asked about? Nice, Puti. Nice, Bongokosi. How did we get the green? Okay, so Loyalo, what we did was if we make tan of theta equal to -2, there's two ways we can do it, but the one way is to go shift tan -2, shift -2, and then you get -63 point da 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 da. Now that's clearly wrong because, well, not wrong, but that's this angle over here. And so then in order to get that one, we add 180 to it because it's on the same straight line. And so if we add 180 to that, we will then get our 116.57. Now that's the one way of doing it. And yeah, I would look at the recording of the previous lesson if you need some more help on that. And so yeah, the red is just going to be, we'll say angle BAC is just going to be 116.57 minus 45. And then 6.57 minus 45. And we get 71.57 degrees. All right. There's one small little question, but we'll come back after the break. I think it's time for some exercise so we can all breathe. So I want you to step away from your computer and I want you to stand up with me. And I want you to indulge your body in some oxygen and some blood flow. All right. So get into a space where you're not going to whack anything. Invest in yourself, I say. take a moment to just let your body, kind of do its thing. So let's start with breathing. So one more nice deep breath. Oh, those breaths are feeling good. Okay, so now we've had some nice oxygen. We're just going to shake our arms around a bit. Get the blood flow going. See if you can get it going in circles. And then shake it out that other way. Shake out your legs. Okay, and then let's a nice shoulder stretch across like this. And switch arms. Then let's do this one. Hold it. And then that one like this. Okay, then let's just do some rotations. So very gentle. And then as you relax, you'll be able to go further. Okay, then it's coming, some cardio. And let's do some air skipping, and we'll do 20 of them. And start in 3, 2, 1. And there we go. We are. Okay, I'm going to leave the mass 24. Actually, no, let's not leave it. Got to do some mass 24. Where is... Here it is. Okay, I'm just going to give you the choice of these two. See if you can solve them. Can you make 24? Who is going to get the glory for the final lesson of the year? Who's going to get blue? Who's going to get yellow? Okay, so Fatejo has gobbled up the blue one. 6 times 3 is 18. Fatejo plus 5 plus 1, which gives you 24. Awesome. Can anyone do a yellow? Could I do the yellow? Let's have a look. 4. Some of these are quite tricky. 8 times 4 is 32. No. 4 divided by 8 minus 4 is 4. Oh, this yellow one is tough. My brain is not... We might have to come back to this one. 4 plus 4, 7. I'm trying to make factors, but I'm not getting there. 8 minus 7. No. 4 plus 8 is 12. Koteko, you better hit us with your answer, otherwise we're going to have to move on. Oh, this is a toughie. Okay. If anybody gets, 7 times 4 is 28. Yep. 8 minus 4 is 4. 28 minus 4 is 24. Wow, Fateko, you are like the Maths 24 champion. Well done. Well done. You do you have to you're gonna have to go to the world champs. Okay. Oh, where was I? Exam questions. Okay, let's just finish off this question. So the last one is, it says in triangle ABC, determine the equation of a line from C perpendicular to AB. So if we think about C perpendicular to AB, it's got to come from this point C, and it's got to be at a right angle to this line. Now, we do know from earlier in the lesson that the gradient of AB was 1. So can you use the fact that you know the gradient of AB, you know the blue line is perpendicular to that line, can you figure out what the equation of the blue line is? I want you to try and do that. And then we'll have a quick glance at if there's time, some trig. Ask yourself, what is the gradient of the perpendicular line? We can even call it the red line. If I know that AB's gradient is 1, well, because this is perpendicular, when I multiply them together, I need to get -1. So the gradient of this line actually has to be -1. And so now you need to figure out what the equation of that line is. And the reason would be perpendicular lines. So if I look at what point I need to use, the point I'm going to use is a point on the line. So the point is 2 minus 2. And you have to sub that in order to figure out what C is. So -2 equals -1 times 2 plus C. But then this -2 becomes a +2. And so C must be 0. And so actually the final equation is just y equals -1x or -x plus 0, but we don't write the 0. And so the equation of the red line is just y equals -x. Give me a thumbs up if you followed that. That was a proper exam level question. It had a few easier ones at the beginning, and then it got successively harder. Give me a sense of how you're feeling. Where did I get the coordinate 2 minus 2? So if you look here for Tejo, it says that the line has to go from C perpendicular to AB, and C is sitting over here. So it has to go from C, and it has to be at a right angle to the line AB. So what I did was I said, look, the green one, I know already, it's 1. Therefore, something that's perpendicular to that, its gradient will be -1. So that's where this -1 came from. And then I've subbed in the point 2 minus 2, and I found that C was 0. And so eventually the equation would just be that, but we don't write the 0. Leisure. Okay, I don't know if I have enough time to grab a trig graphs question. Let's see if I've got one. If I can find one just to finish off. We did this in the last lesson, I think. Writing questions. Oh, we could do this. Let's do a couple of these guys, these multiple choice questions. It's a nice way to end. Okay, let's do question 3. So for trig graphs, we're going to do number 3. What is the period of 2 cos 3 theta? What is the period of that graph? Is it A, B, C, D, or E? Which answer do you think is correct? So to find the period of a trig graph, you take the normal period, which the normal period of the cos graph is 360, and you divide it by the number in front. So you should get 120. And so the correct option will be 120 degrees. And what that means is if you draw the graph, each little bit would be divided up into increments of 30, because you get a whole cycle in 120. All right, so let's do another one. Which one should we do? Okay, let's do this one, the range. What is the range of 1 plus sine x? Which of the 5 options do we think that was going to be? Lolo, this is for paper 2, actually. So trig functions are in paper 2. And so if you are feeling a bit uncertain about trig functions, I would recommend going to look at the videos in exam revision or under trig functions itself. I've done hours of lessons on this, but right now I'm just doing a bunch of multiple choice questions that are kind of like exam revision. So just reminding you that the normal sine graph, it looks like this, and it goes to a highest point of 1 and a lowest point of -1. But if the whole graph is shifted up by 1 unit, what you are then going to see is that the graph is going to start rather here, and then it's going to look kind of like that. And so the highest point it gets to now is going to be 2, and the lowest point it gets to is 0. So which of the 5 options do you think is correct for this sine graph? Because remember that the old one, the normal sine graph, goes between -1 and 1, but then because everything shifted up, the lowest value it gets to is 0, and the highest is 2. And so the correct option here would be C. Okay, everyone, we are going to call it a day for today